All right, since we're all here and paying attention. All right, class. Thank you. All right, so I know we're all paying attention. So we're doing higher order derivatives. That means we're not just going to take the first derivative, we're going to take the derivative of the derivative. Now, if you remember when we talked about this previously in Unit 2, I know my first function, okay, do you guys recall what the first function is supposed to be? So if it was my f of x, what does that give me? In the function, if we are talking about it in terms of no, my face. I'm keep looking over there. I don't know why I'm looking at myself, but yeah, I'm weird. Huh? Yes, I do. Okay, so because I'm trying to remember, like specifically, if you're taking physics, what was the first function actually give you? Did I hear position? I'm hoping I heard position, right? You guys, it's been a long weekend. Yeah, I know. It's yeah. So yeah, this is a rough Monday. Okay, so yeah. Okay, so it's normally like an you see it like an S of t, which is position over time, right? Yeah. Okay, so if I take the derivative of the position, I get velocity, right? So then I get v of t. Okay, so velocity. So, and if I take the derivative of the derivative, I get the acceleration. I get a of t. So there is a reason for doing this all the time on these, okay? So this is what we do using physics on all of these, okay? They are useful. So we're going to go through this and do this again, but now this time we're going to use the implicit differentiation. There we go, okay. So I'm going to start off with, I get y squared minus x squared equals 5. And we're going to go through and do the first derivative here. So what is going to be the derivative of y squared? 2y. You're almost 100%. Like 99%. dy dx, right? So we have to add the dy dx because I'm taking the derivative of something that's not the x. So this is going to be 2y dy dx minus derivative of x squared, 2x, equals, what's the derivative of 5? 0. There we go. And I want to try and get my dy dx by itself, right? So I want to get that by itself. So I am going to start move it, because we like to move it. Thank you. All right, I'm going to add 2x to both sides. So I'm going to get 2y dy dx is equal to 2x. And then to get my dy dx by itself, I do what to both sides? Divide by 2y. So I'm going to get that my dy dx is equal to 2x over 2y. And what's going to happen right there? I'm going to cancel out the 2's, right? So I'm left with x over y. And that is going to be my first derivative. Okay? That's my first derivative. Now, I want a second derivative now. So I'm going to take the derivative of the derivative. So I have that dy dx is equal to x over y. Okay. Now, in this case over here, the x over y, what is that? What type of rule am I going to use there? Quotient rule. I'm going to use quotient rule, right? So I'm going to do my f and g here. This is my f, this is my g. So f prime would be 1. G prime is 1 dy dx, right? Okay, that's important. So I'm labeling everything. So now when I take the derivative of the derivative, this is now going to imply that I'm going to have the second derivative here. So the second derivative is going to be, so there is my second derivative is equal to, now quotient rule says f prime g, so f prime g, so that's going to be 1 times y minus g prime, which is 1 dy dx, times f all over y squared. Okay, now can everyone tell me a problem that we might have here? The fraction, kinda. Is this supposed to be the second derivative? Yeah. It is supposed to be the second derivative, but my problem here is my second derivative has what right here? It has the first derivative in it, doesn't it? Yeah. Okay, so when I have that and I do this, I have the second derivative is equal to all this, but inside there is the first derivative also. So all I have to do is replace my first derivative, but what is my first derivative? X over y. So I'm just going to replace it there. So I get my y minus x over y times x. It's going to give me x squared over y divided by y squared. Did I lose anyone? Yes, because this is just going to be x over y. So it's going to look like this, x over y. When I multiply this, x squared over y. And then I'm going to clean it up a little bit. Okay, so multiply, so that's going to be y over 1 minus x squared over y. So, right here, fraction by fraction multiplied by the reciprocal of the bottom. The reciprocal of the bottom is going to become 1 over y squared. So as I distribute that in, to this first one here, one of my y's is going to cancel. Yes? Yeah. Okay, one of the y's is going to cancel, so I'm going to be left with just 1 over y minus, I don't know how many y's canceling over here on the second one, so it's going to be x squared over y third. Very good. There we go. And so that is my there we go. Now, on the free response test, okay, when you're taking the AP on the free response test right here, you do not need to simplify. Just leave your answer as that. Okay, multiple choice answers. You'll probably have to reduce, simplify to get your answer to look like their answer. Yes? No? Maybe? Possibly. Now, you guys see right here, using Leibniz notation, the dy dx. Remember when we were doing the problem yesterday and I was just using y prime? Yeah. And it just looked like it was y to the first power. Wouldn't that would look really, it would be easily overlooked in a problem like this, wouldn't it? So that's the reason why doing this notation is helpful. All right, so I express it in terms of x and y. So if you notice, it also did not say in dy dx, that means that you had to replace all your dy dx's with x and y, and that's what we did. All right, questions before I keep going? No, this is all the same stuff. These are all the same. It's just now we're using x's and y's.
Is there going to be a z?
This is all implicit. Yes, there is, eventually. Eventually. Or an r. There might be an r.
Radius?
Yes, that is going to be a radius because we're going to take the rate of inflation of a balloon. Because we're going to see how the rate r changes over time. So.
Don't do it.
Yeah. Actually, those are some of the easiest ones.
Yeah, I mean, spare me. It'll be fine, yeah.
Okay, so rewrite this one. So, and do it correctly this time. How would I write that one? That's going to be x to the what?
I want to say the wrong answer.
1 over 2? Yes. This is x to the 1/2, right?
Yeah.
X to the 1/2. And as I take a derivative of that, the 1/2 goes out front, and I subtract 1, or in this case 2 over 2, right?
Yeah.
I subtract 2 over 2, so this is going to give me 1/2 x to the negative 1/2. And if I want to rewrite that, the negative 1/2 would go to the denominator, right?
Yeah.
Okay. So I'm happy with that one there, though. What about this one right here? B is going to be 3
over 2.
u to the
1/2.
1/2. Very good. Again, that 1/2 has to go out front. And what are you going to get? 3 over 2 u to the
Negative 1/2.
All right. So Denny, are you ready for this next one? Because Denny's got this one clutch. You ready? All right. So I don't need to rewrite this one, do I? Because it's already there, right? So what's that one going to give me? What goes out front? Yeah, 5 over 2. 5 over 2 x to the what? 3 over 2. Very good. Because you're subtracting 2 over 2, right? You're subtracting the 1, which is 2 over 2. All right. Meow meow. You ready? All right, this one's already set up for me. What am I going to do first? What goes out front? Negative 3 over 2. And that's going to be S. And what do I have to do? What do we always do for the exponents? We always subtract how much? 1, right? But my 1 is a fraction, isn't it? And my fraction needs to have a common denominator of 2. So isn't that just 2 over 2? Yeah, that's still 1. So now subtract. So subtract 2 over 2, which gives me go bigger, because you already start with the negative, right? You start with the negative, so to subtract you get a bigger negative. It's kind of like your bank account. If you're in the negative and you spend more money, yeah, you get a bigger negative. So negative. Yeah, so you're subtracting 2 over 2, right? So it's negative over. I know, putting you on the spot. Right there.
I got confused with my penmanship too.
Where's your notes?
What do you mean?
Like the actual paper I gave you.
I put it in here. No, I put them too, but whatever.
But the actual paper that has everything written out. It's in your bag somewhere?
Why it's on the board anyways. I
Okay.
put everything in here.
Okay. But I don't want your own penmanship to, lead you astray.
No, my penmanship when you wrote the pattern.
Oh, okay. How dare you. Anyway, all right. So, all these things are stuff that we've already done. All these things are stuff that we already done. Okay, so this one right here is going to be a U, right?
Yeah.
Okay, so this is going to be a chain, and the inside is going to be what?
Yeah.
Okay, it's going to be my U, right? So U is S cubed minus 2S plus 1,
Looks like an 8.
right?
Yeah.
I know, it looks like this not so smart board is not so smart. And so, yeah, anyway. So, U prime, what would my U prime be? There we go. So 3S squared minus 2. And if I come over here and I say U is, not U. What's it? It's U to the what value?
U to the,
Like my fat head's in the way and I can't get this. So U to the 5 over 3. There we go. U to the 5 over 3. So taking the derivative of the outside now, so I have the inside, outside, so the derivative of the outside is going to be 5 over 3, U to the 2 over 3, very good, times
times the U prime.
U prime, right, which is 3S squared minus 2. All right, and then my last thing is, last thing, it's not done. Put it back, right? Put U back.
Put it back, okay.
Because right now, our problem doesn't actually have any U's. It's all have S's, right?
Yeah.
But to chain, I subbed with U, right? So just plug it back. So that's going to give me 5/3. Now, if I'm multiplying by all this over here, I could clean it up in the end, if I want to. All right. S cubed minus 2S plus 1, and that's going to be to the 2/3 times there you go. So if we wanted to do this, I have a binomial times a trinomial, and then my 5/3. I could put my 5/3 into my second term over here. I wouldn't put it in my 2/3. I would not do that. Because that means that my 2/3 is a square, so that's a power. And then the over 3 is the third root. So I really don't want to mess with those. I don't. Just leave it out front. It's going to be a hot mess if you try to. All right. That being said, okay, so let's try C. Let's try C. I want to see you people do C for me now.
Did you sing yourself yesterday?
Quite possibly. I can't remember anything anyway. I've been every which way because my other college is giving finals, and then, of course, you know, like 5 of them didn't take their final, and so, yeah, even though that, all the other issues that they have. So everything's a sad story. Arizona Western. And then, to ask you about that, something test or something that we have to give,
Oh, the power assessment.
something weird. Like, I just got an email from, no, nope. I think someone at mine,
You can pull it up.
you're here next hour, doing
Yes, college man?
Yeah.
Okay, that was, I was trying to look back on that.
All right, so we have. Negative 304. All right. So, let's start with our chains. What are we going to identify as my U?
3 theta.
Okay, so let's start with the outside first.
Oh, is that okay?
Yeah, go for this outside first.
Can I choose what?
You just choose the whole thing.
Okay.
That's easiest, right? U is tan 3 theta.
Oh, you choose one.
Okay?
Okay.
Yes?
Yeah.
Okay. So, and then because of that, I have an inside also, right?
Yes.
Okay, I have an inside of that also. So if I were to take the derivative of this, I would also have a v.
Yeah.
Okay, so I would have a v also. So my v would be 3 theta. Okay, so v is 3 theta. So v prime is going to give me 3.
Just.
Yeah. What's the derivative of 3 theta?
Okay.
Yeah, just 3, right? It's kind of like just 3x. It would just give me 3, wouldn't it?
Yeah.
Because theta is my variable here. So now I have that. Now, let's go up here. And what's the derivative of tangent? Secant squared?
Yeah.
Secant squared. So u prime is going to be secant squared. So when I do that, that's going to be secant squared. So SE secant squared of 3 theta. So step by step identifying each part. And let's go all the way over here to my u now. So u is going to be all this right here. Oh, not u is. U raised to the negative 3 over 4. So let's take the derivative of my u now. So I start by building it. I got to my smallest part in all the insides, and now I'm on to the outside. So the derivative of u to the negative 3 over 4 negative 3 over 4 u to the
-7/4.
-7/4, right? Because the common denominator is 4, so it's subtracting 4 over 4, right? Okay, so -7/4 times, okay, times, let's go down, u prime, so it's going to be my secant squared of 3 theta times v prime, derivative of the inside, which is 3. And then my last thing there is, I could multiply that out, but also, I still got u's, don't I?
Oh, yeah, you plug it in.
Sub it back. So sub it back. So by doing that, let's see, and the 3 could go out front too. So 3 can go all the way out front, so that'd be a -9/4, and my u is going to be tangent of 3 theta, and that's going to be to the -7/4 times secant squared 3 theta, and then the 3 already came out front. All right, questions, concerns, complaints, conspiracy theories. It's not a conspiracy, it's true.
What's considered conspiracy theory to you?
I don't know, because I believe it all. Aliens are real. Government even said they're real now, finally.
We even do it, it was during COVID time.
I know, Aaron's like, okay, all right, okay. I know, they're like, guess what, aliens are real. All right, so now here, yeah. I know it is. I know. Yeah, don't pay attention that we're taking away everything that you thought that you owned. All right. Other than that, okay, make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from the merch store.